Hello everyone, welcome to The Extraordinaire. We're going to continue from where we left off in the previous episode, and that is break and continue statement. The break statement breaks out of the innermost enclosing for or while loop. Let's take an example. For n in range 2, 10, for x in range 2, n, if n modulo x equal to 0, print format n, opening and close parenthesis, x, opening and close parenthesis, asterisk n double / x, and closing double quotes and closing parenthesis. And we'll have our break statement, and this is what we get. So what's happening here? In this first line, we have for n in range 2, 10. This gives us a range of numbers starting from 2. Just like we learned in an earlier episode, the range gives us a sequence of numbers, and when we give it two arguments like this, the first number is used as the starting point, while the second number is used as the end point. And the end point is not included in the sequence of numbers that are being returned. So for this case, we're going to have n taking the form of 2 to 9. For the second loop, we have x in range of 2, n. So whatever number we get from here, we're going to have an inner loop that is creating another sequence of numbers based off that number. So when we have, for example, we have 2, we're supposed to have a range here for 2, but we can't have that because this range is going to be 2, 2, which is not going to give us anything. It's just going to be an empty set. Then we move on to when n is 3. When n is 3, the range here is going to be 2, just 2, because the n here will be 3 and 3 won't be included. So the n here will be 3 and 3 won't be included in the sequence. So in this case, x is 2 and n is 3. Then we come here and perform this test. N is 3 and x is 2. So we do a modulo of 3 modulo 2, which is going to give us 1, and 1 is not equal to 0. So this if statement is not going to be true, which means that nothing happens here and we just go and do the loop again. But now there is nothing to test again in this loop, so we go back to the outer loop, and at this point we are moving to the next sequence, which is 4. In the case of 4, for the inner loop is going to have 2 and 3. 4 is not going to be part of the range because the fourth item is not included. The last item is not included, and just like before, 2 is not going to be able to pass through this line, and 3 would not be able to pass through this line. So we go back again to 5. So, and what we have in this line for 5 is 2, 3, and 4. And we've already established that 2 and 3 would not pass through this line. But 4 is going to pass through. Why? Because 4 modulo 2 is equal to 0. The remainder of dividing 4 by 2 is 0. So that passes through and it prints this print statement. And once it does that, it breaks the loop. But it is only breaking the innermost loop. So it's going to go back out to the outer loop, and this time it's going to try for 6, and it will do the same thing for 7, and to do the same thing for 8, and it will do the same thing for 9. That is how we get this print statement that we have here. So basically, the break statement helps us to break out of a loop. What about the continue statement? The continue statement continues with the next iteration in the loop. Let's see an example. For num in range 2, 10, if num modulo 2 is equal to 0, print f found an even number num continue, then print f found an odd number num. And we have found an even number 2, found an odd number 3, found an even number 4, found an odd number 5, found an even number 6, and so on and so forth. What's happening in this case? Just like the previous example, we have a sequence from 2 to 9, and then we test each number in that sequence. So what we're doing here is we say if, for example, if 2 divided by 2, what's the remainder? If the remainder of 2 divided by 2 is equal to 0, then we print found an even number, and then we print that number. And in this case, yes, the remainder of 2 divided by 2 is 0, so we print 2. And then we continue. This continue takes us to the next iteration, which means that this print statement down here, we don't get to it. We just skip from this point to the next iteration. If we were to remove this continue, let's do it again and remove that continue. Range 2, 10. Then we say if num modulo 2 is equal to 0, print f found an even number and then we say print f found an odd number as you can see, it is repeating itself. So it does found an even number, and then it goes ahead and it prints found an odd number for the same number, which it's not supposed to be doing. That is the essence of this continue statement. The continue statement allows us to skip to the next iteration, to continue to the next iteration, while the break statement, it stops the iterations completely. So if we have an iteration, if we are looping through a sequence and we have 9 steps, if we put a break on the 5th step, no other step is performed, right? We just break the iteration. But if we put a continue statement instead, it just skips to the next. It doesn't perform any other statement. It doesn't do any other line of code, doesn't read through any other line of code, just skips to the next step. Let's take a look at the next thing. Else clauses in loops. In a for or while loop, the break statement may be paired with an else clause. If the loop finishes without executing the break, the else clause executes. In a for loop, the else clause is executed after the loop finishes in its final iteration. That is, if no break occurred. In a while loop, it is executed after the loop's condition becomes false. In either kind of loop, the else clause is not executed if the loop was terminated by a break. Of course, other ways of ending the loop early, such as a return or a raised exception, will also skip execution of the else clause. This is exemplified in the following for loop, which searches for prime numbers. Let's clear out this screen. We import OS, and then we say os.system clear. And let's take a look at this example. For n in range 2, 10, for x in range 2, n, if n modulo x equal to 0, print n equals x asterisk n for /x, or we break, else print n is a prime number. Cool. Now what's going on here? In this first line, for n in range 2, 10, we'll get a range of numbers from 2 to 9. Let's take a look at it. So we say list range 2, 10, we get 2 to 9. Now for each of these numbers, we are going to do another loop which is going to use the number in each of these as the endpoint. So for in the first instance, we have n is equal to 2. So we have range 2, 2, which is just an empty list. So this break statement won't be run, and so we just print n is a prime number, which prints 2 is a prime number. Now let's check for 3. If we do the same thing, but this time around n is equal to 3, we get 2 as the only item in the list. So x will be equal to 2. But now if we do this test here, this if test here, 3 modulo 2 is 1, which means that this test is going to be false. So in that case, break would not be run as well, and so we just print n is a prime number, which prints 3 is a prime number. Then we go again for the next item, and we've already established that we are going to have 2 and 3 not passing through this statement. So what we pass through this statement is 4. So if we do 4 modulo 2, we get 0. 4 modulo 2 is 0, which is equal to the 0 here. So this statement becomes true, and then we print 4 is equal to 2 times 2, which is what we have here, and then we break out of the statement, and every other thing follows suit. So that's how this simple program works, and that's how the else statement is used in for loops. It can also be used in a similar way for while loops. Pass statements. The pass statement does nothing. It can be used when a statement is required syntactically, but the program requires no action. For example, while true, pass. So it does nothing really. It's just like a placeholder, which we have here. Another place pass can be used is as a placeholder for a function or conditional body when you are working on new code, allowing you to keep thinking at a more abstract level. The pass is silently ignored, so it doesn't really do anything. If we define this init log args, for example, and we say pass, even if we call this function, let's just put a number here, nothing happens. So pass is just used as a placeholder basically. The match statement is really involved, so I'd like to dedicate a single episode to it. We'll continue with the match statement in the next episode. If you like the content, please like and subscribe and share with those that you think would like it as well. See you in the next episode. Bye.